So I think we went through the first handful of questions from the homework. When you're graphing sine and cosine, there's an amplitude in the problem. What does the amplitude do to the graph? Shrinks or stretches it horizontally or vertically? Vertically. Okay, so the amplitude affects the y of the graph by multiplying the y by that amplitude. So it's either going to stretch it vertically or shrink it vertically. And the three that you had to graph looked great. So I'm not concerned with graphing amplitude. It's just changing the y value of the graph by multiplying by that number. To stretch it or shrink it vertically. So today we're going to look at the next letter in the equation, which is a b. They just go in order. And now we're going to stretch it horizontally or shrink it horizontally. It's a little trickier though, because the horizontal part is the angle. And you can't just quick multiply an angle by a number because it doesn't work quite as nice and neat as that. So we're stretching it and shrinking it horizontally, but we're going to have to do a little bit of extra thought process behind it instead of just quick looking at the y values and multiplying y by that number. Tomorrow we'll start shifting it. So there's 4 letters in the equation. There's an A, a B, a C, and a D. All 4 of those letters change the graph in a certain way. And so our goal by, if not the end of tomorrow, the beginning of class on Thursday, would be to kind of know what all of those letters do to the equation. How does it shift the graph? How does it stretch or shrink the graph horizontally or vertically? And then Friday, you'll be given a graph, and then we'll be doing the other way. Like you'll have a picture. How can we come up with an equation, which is what we did with parabolas. If you didn't have a picture yet and information about it, we tried to come up with an equation, so we're kind of like working backwards. So in your notes packet, page 8, you'll want a piece of graph paper next to you as well, unless you want to try and see the grid that's on your paper. It's a little hard to see, but we'll be graphing 2 problems today. 2 examples that has a change or a different period, and we'll talk about how to find that. So just have a piece of graph paper handy, and then I should be able to pass back the tests the last minutes of class. There should be time to do that. So we're looking at where it says period, which is the horizontal stretch or shrink of the graph. So if it's horizontally, we're affecting x, which is really the angle. Vertically, you're affecting y, which is the actual value of sine or the value of cosine, depending on that angle you're given. So you see the 2 equations. We're now adding the extra letters. So the A changes the amplitude. So A is for amplitude. The B changes the period. And then again, we'll start adding a C and a D to have 4 different kind of translations of a graph. So a little bit of explanation underneath, just using the sine equation. You can use either equation. I just chose to write sine here. What we did yesterday was y equals A times the sine of x. That graph started at the angle of 0, and it went to the angle of 2 pi. Your unit circle starts at 0 over here, rotates all the way around, and then goes back to 2 pi. Now we're going to switch that a little bit, and that's going to change based off of the number that's with x. So it's going to be after the sine, before x. So it might say like y equals the sine of 5x. The number with the x is now the number we're looking at. So if it's in front, totally in front of sine, that changes the vertical part. If it's with the x, because it's attached to x, it's affecting x, so that changes then the x value, the angle value. So instead of my x value starting at 0, now there's a number with it. So now we have to say some number times x starts at 0 or is equal to 0, because that's where it usually begins. That same number times x has to stop at 2 pi. And then if we solve that little equation underneath here, dividing by b to get x by itself, our graph will still begin at the angle of 0 because we're not shifting it. So it starts at 0 until we start moving the graph left or right. We're just stretching. However, our last value for the angle will now go up until 2 pi divided by b, which is how, that was number 3 in the book, I think? I think number 3 in the book book, it asked about the period. And if there's a b value, whatever your typical period is 2 pi. We're now going to be dividing it by that b to get the new distance, however it's stretching or shrinking. So it says, therefore, the period of sine or cosine starts at 0 and ends at 2 pi over b. This here is the new period. So instead of it ending at 2 pi, it's going to end at, 4 pi, 8 pi, 2 pi over 5, pi over 6, depending on how short it is or how long it is. It's the b value that changes that. The last little piece of information that it tells you underneath, if your b value is between 0 and 1. So Brandon, give me shouldn't ask you, but I'm going to. A nice fraction between 0 and 1. Not crazy, nice. Okay, good, that's it. So if the b value was 1/2, that's between 0 and 1. What does that actually make the period, Brandon?
Pi.
So what is 2 pi divided by? 4 pi. So you can see that if this is b, my period now actually doubled, because when you're dividing by 1/2, you're really multiplying by the reciprocal. So your period stretches when you're dividing by 1/2 or you have a b value less than 1. The other way around, it's flipped. It says if b is greater than 1, so we'll just say 6 maybe. So right here's b. b is 6. Then that makes pi over 3, and now that has shrunk because now it's less than 2 pi. So 2 pi is the standard value. That's our normal value because it's one rotation around the circle. So if the number for b is in between 0 and 1, that number then stretches. If it's bigger than 1, then our end result for the period actually shrinks. The last little part underneath says if b is negative, we're going to use these two facts. These are the negative angle identity facts, or the fact that the sine is odd and the cosine is even. So even if you have a negative angle, the negative angle part, when it's sine, actually makes the function negative. And that was one of the questions on the test. So if you had the sine of negative t, it's actually equal to negative times the sine of t. Where cosine, if you have the cosine of a negative number, it's actually equal to the cosine of the positive number. And that goes back to making a triangle. You don't have to draw this picture, but this is how we kind of talked about it. But I'll keep it as t. But if we had the sides of the triangle just labeled 3, 4, and 5, the sine of the angle would be 3 over 5. But if I take that same angle and make it negative, this has to change to negative. Now the sine is equal to negative 3 over 5. That's what this is saying here. So the sine of a negative angle is really equal to a negative sine value because you're underneath the x-axis. That's what a negative angle does. It takes you underneath the x-axis. Whereas cosine, if I have a negative angle for cosine, it's still 4/5. It's still a positive value because cosine is x. You're not going underneath the x-axis. You're staying on the x-axis. So that's how that works. We'll use that fact intermittently, but sometimes we just graph the negative angle and then we just kind of continue on. And as we graph more, you'll see how that changes. Questions? So if you look at the first example, it says sketch y equals the sine of x over 2. So we're going to start introducing multiple letters here, and just to kind of get you to think about what all of them mean and what they do to the equation. Now we have 2 letters that we're talking about. The a is in front of the sine, the b is in front of x. So Chelsea, the number in front of sine is 1, but the number in front of x, or with x, is 1/2. So that x on the top really has a 1 on front. You could write this as the sine of 1/2 times x. That means the same thing as x over 2. So the a value, the number in front, and the b value is the value that's attached to x. A helps us find the amplitude. So if the A is 1, the amplitude is the stretch from the center to the top of the graph. B helps us find the period by taking our typical period, which is 2 pi, and dividing it by that B value. That's how you get your new period. And Brandon, we just did this one, because you gave me a half. So 2 pi divided by a half is 4 pi. So that's how you calculate your new period. So you take the original period, the standard period, you divide it by B. Questions? So there's one other thing that we now have to do. We have to graph it, and in order to graph it, we are going to be looking at how that period changes our points. Because now our graph goes to 4 pi, where before it only went to 2 pi. So we are going to talk about those key points. You're asked to graph 5 key points, label 5 key points, list 5 key points, whatever you want to say there. To find the value that we're going to use, let me erase this first. So typically, the graphs that you did for homework last night, the 3, and then the 2 that you did in the little warm-up quiz, what did you count by to go from one point to the next? What were the increments? Chelsea? 3. So, say again? 3? How many increments were on your graph? How many sections were on your graph? Maybe I'm not using the right word. If somebody has their graph out?
Counted 8 left, 3.
Okay, so yes, you can. I see. I'm using the wrong word. Yes, you had 3 spaces to get to that first spot. Well, what is that? What was that first angle? Pi over 2. And then the next angle was pi, because if you add pi over 2 and pi over 2, you get to pi. And then you add another pi over 2, you get to 3 pi over 2. How many sections, like just on the positive side of the graph, how many sections do we usually divide our graph up into? 4. So here is 1 section, 2 sections, 3 sections, the 4th section. So in order for us to decide how to get these labels at the bottom, we're going to take our period and cut it into 4. So we'll always graph 5 key points, but 5 points divides a graph up into 4 different sections, 4 different intervals. So that 4 also correlates with the circle that has 4 intervals, 4 units, 4 quadrants in the circle. So our period, we calculated, was 4 pi. If we divide that by 4, you get the value of pi. That's what we're going to count by to go from one angle to the next.
If you are a twin, a triplet, or a quadruplet, could you please come to the main lobby for your book photo? Thank you very much.
No, none of you.
How is a quadruplet from swarms?
Are there quadruplets?
Yeah.
Oh,
Like Katie, Marie,
yes,
Jess.
yes. Jess, I had Jess last year. Yes.
She was in our group with Ethan, yeah. Like it was me, Zach, or no. It was me, Derek, Ethan, and Jess.
Yes. All right, so to find our new angles, the first angle still starts with angle 0. Because we're not shifting, we're still starting at 0. What is the next value going to be just for the angle? Pi. Because now this is the number that we're using to go from one angle to the next. So Brandon, your third angle would be 2 pi. Your fourth angle is
3 pi.
and then your last angle would be
4 pi.
4 pi. So you're using this key point value to find the angles of your graph. So instead of having pi over 2, pi, 3 pi over 2, 2 pi, we're now counting by pi. We're increasing by pi. Questions? So looking at the y values, the sign of 0 is 0. So the first y value is still 0. The second value says pi, but if you go back to your equation, it's really pi, because that's x, divided by 2. So the sign of pi divided by 2 is 1, which was the same original y value. So the y value isn't changing. The next one is 2 pi, but if you take 2 pi divided by 2, you go back to pi. So that y value is 0. And then we have 3 pi. Well, 3 pi divided by 2 has a sign value of -1. And then 4 pi divided by 2 has a sign value of 0. The y values are not going to change. So it's still 0, 1, 0, -1, 0. They're not changing just because that angle is changing, because that angle goes back to the original equation. Questions? So we're going to graph this. We're going to use those values. Technically, the look of your graph is not changing. The part that's changing is the labeling of your graph. So when you graph tonight, you're going to look at your graphs and be like, besides the amplitude stretching the graph, they all look exactly the same. But the units that you're using now is a pi instead of it being a pi over 2. And right here is 2 pi. So that would have been the distance of my original graph, but now it's continuing to stretch past 2 pi because it's going to 4 pi. So the graph is stretching, it is doubling in size, because typically we end at 2 pi, now we're stretching it to 4 pi, but visually it's going to look exactly the same. So plotting your points starting at 0, at pi we're up at 1, 2 pi we're down at 0, 3 pi we're at -1, 4 pi we're back down at 0, or back up at 0 I guess. So like that graph looks exactly the same as the sign graphs that we graphed yesterday, the sign graph that was on your little warm-up quiz. It's just the units, the labeling is different. So yesterday, we would have graphed just to 2 pi, and I would have had 2 curves there. Now today, we're graphing to 4 pi because the graph has really stretched. It's doubled in size. Questions? So there's one other example, but I'm going to just switch this a little bit and add a 2 in front, just to make it a little more interesting so we have another number to look at. Because most of the homework problems, you'll be focusing on not only the period, but also the amplitude. So just plugging in an extra number there. So the A value is 2. That means the amplitude is 2. That's the stretch of your graph. How high is it stretched vertically? The B value is 3. How do we find the period? Brandon?
2 pi.
Right, so it's 2 pi divided by B, and in this case, B is 3. Now, don't give me a decimal. Always keep it exact. So we're looking at the value 2 pi over 3. That's now the distance of our period. So it's shrunk. It's less than 2 pi instead of being more than 2 pi. And then the last thing that you need to find would be what we're using as our key point. And that's when you take the period and divide it by 4. Always 4, it never changes. There will always be 4 sections of your graph. There's 4 quadrants in the circle. The graph will always be divided by 5 points, but giving you 4 equal increments of your graph. How can you take 2 pi over 3 divided by 4, Chelsea?
Just multiply by this.
Yeah, multiply by the reciprocal of 1/4. Do you know what that simplifies to, Chelsea? Pi over 6. So this pi over 6 value is what we're going to use to get from one angle to the next. So you're counting by the increment of pi over 6. So starting at 0, I'm just focusing on x. Then we have pi over 6. So it's always 0. The next angle is pi over 6, because you're increasing by pi over 6. And then you're just taking pi over 6 and your angle and continuing to add. So the current angle increase it by pi over 6. So Libby, that becomes 2 pi over 6. So then that would be
Pi over 3.
pi over 3. And Libby, if we take pi over 3, which is really 2 pi over 6, and add pi over 6 to it, you get
Pi over 2.
pi over 2. That's a sloppy looking pi. So now we have 3 pi over 6, which is pi over 2, plus pi over 6, Libby, so that makes,
2 pi over
right, because it's 4 pi over 6. So this is my work over here, just to kind of show you how you're creating that angle. So you're taking the current angle, you're adding pi over 6, so that you have equal increments between each space, or between each point. And then I switched this to have a 2 in front, just so we could change the amplitude. So your amplitude, your y value, you're taking 2 times y. So for the last problem, it was originally 0. 2 times 0 is still 0. And then the next point was originally 1. Well, 2 times 1 is now 2. You go back down to 0. Point 4 is usually a negative 1, so now we're at negative 2. And then you go back down to 0. So for sine, 0, 1, 0, negative 1, 0. Those numbers aren't changing. So horizontally, again, this graph looks identical to the one that we graphed, right next to it, or right above it, wherever you're graphing. Now, vertically, we're switching it because it's going up to 2, so it has a vertical stretch. Technically, horizontally, it's shrinking because we're only going to 2 pi, but you physically don't see that shrink in the graph. And try your best to make them curved. I know it's hard when it gets long and narrow. Questions? So I'm going to pass out your test really quickly. See if I can be quick.